Chaining is another collision handling algorithm. With chaining, you have a linked list starting in every one of these cells in our hash table. So here is our hash table of size 10, just as it was before. Don't worry about this grayed out portion here. It has no significance. It's just the way I created this table and I couldn't get rid of the gray. Here are the 9 keys of the objects we want to put in our hash table and the hash values of each of these keys. So pineapple was a 9. We go to 9 and we add it to an initially empty linked list. So we append and we get our pineapple information as the first element in this linked list. Similarly, grapefruit, first element of the linked list, rooted at the 0th element in this table, this hash table, which itself is an array. Apricot goes in at 7, so it would be the first element of this linked list. Let's just go through here a minute to coconut. Coconut is a 7, so it would go in as the second element. So again, I'm just appending onto my linked list that is coming from or rooted at the index 7 in this table. So in a similar way, we want to calculate the number of comparisons to find everything. So how many comparisons did it take to find grapefruit? Well, 1. The same for passion fruit, 1. What about apple? 1. What about mango? Well, it took 2 because it wasn't here, but it was here. Similarly, banana is 1. Mango is 2. Apricot is 1. Coconut is 2. Pineapple is 1. So if I add these all together, 1 plus 1 plus 1 plus 2 plus 1 plus 2 plus 1 plus 2 plus 1, I get 12. And I wrote it over here. So with chaining, the number of comparisons to find everything is 12, which means that the average number is 12 divided by 9. If I compare that with linear probing over here, the total to find everything was 23 compared to 12, so it was double the number almost, and the average was 23 divided by 9, which is almost twice 12 divided by 9. Let's look at the number of comparisons to find that something is not here. So how do you find that something is not here? If it were hash value 0, I would be looking at this linked list. And I would go through my linked list looking for it and finding out that it wasn't there. When I go through my linked list, think of a while loop. You are in a while loop. You will get out of your while loop if you find what you're looking for. And this while loop traverses your list. So the maximum number of times you go through the while loop is the length of the list. So how many comparisons to find out that something with hash value 0 is not in my list? Actually 1, because 1 gives me the first element in my list and it's not grapefruit, and I do not go on to a second element because I don't have one. So my loop I only go through that loop 1 time. The same with this is 1. How many to find that something with hash value 1 is not in my list? Well, with a while loop, I am going through that while loop for the length of the list, but the length of this list is actually 0, so I will not at all go through my while loop. So I make 0 comparisons to find out that something with hash value 1 is not in my list. The same thing for 3 and 4. For 5, I'm going to go through this while loop, and I'm going to go through it 2 times because that is the length of my list. And each time I'm going to find out that this is not what I'm looking for and this is not what I'm looking for. So 2 comparisons to find out that something with hash value 5 is not in my table. And the same for 6 and the same for 7, and it's 1 for 9. So 1, 2, so actually if I count everyone, it's 1 for hash value 0, 0 for hash value 1, 1 for value 2, 0 for 3, 0 for 4, 2 for 5, 2 for 6, 2 for 7, 0 for 8, 1 for 9. And if I add those all up, it comes to 9. So the average number of comparisons to find out that something is not in my table is 9 divided by 10. Less than 1. Less than 1 comparison to find out something is not there. With linear probing, we calculated it was 55 divided by 10, 5.5. So there's quite a big difference here between linear probing and chaining. Again, it is not always so. It depends upon your hash function. So it's critical to find a good hash function that doesn't have so many collisions, because the more collisions you have, the longer these chains will be. And just as a hash function that made everything, say 3, with linear probing and made these great long chains, here it would be a very long list. And so to find something, or to find that something is not there, it would be the exact same thing as with a sequential search. So you want a hash function that divides things out fairly nicely and doesn't have very long chains. But chaining, generally speaking, better than linear probing. And there's another advantage. With chaining, I could put 100 things in this table. I would have longer chains, but I could put 100 elements in this table. With linear probing, you're actually constrained. You can only put 1 element in each of these slots. With a table of size 10, the maximum you can put in is 9, because you always want to have 1 space. The reason you want 1 space is so that if you're looking for something, the space is when you know that it is not there. So in order to find out that something is not there, you need at least 1 space. So a table of length 10, the most number of things you can put in it is 9. Whereas with chaining, you can put thousands in here.